Example 15D. So what we want to do is try to get an idea of what y equals the modulus of x plus 3 added to the modulus of 3x minus 2 looks like. So we're going to use this graph here and we're going to plot some things accurately just to get an idea. So let's start by looking at mod x plus 3. Now you should know what this looks like. So when x is negative 3, this takes the value 0. And if we go off to the right, because it has to stay positive, it's actually going to be the line y equals x plus 3. But we know the part of that line that goes below will reflect back up over here. So it'll have a gradient of negative 1, and if this carried on down, it would have an intercept at negative 3. So what we're saying is that this part to the left of negative 3 is y equals negative x minus 3, but to the right of negative 3 we have y equals x plus 3. Now let's do the same analysis on mod 3x minus 2. The value of x that makes this 0 is 2/3. So we're going to get a limb that goes from 2/3 up this way, and that's actually going to be the line 3x minus 2. But then when we get to here, it reflects upwards. So if you reflect upwards an intercept of negative 2, it will go through plus 2. This limb is y equals negative 3x plus 2. And this limb here is y equals 3x minus 2. This one here transitions at negative 3, so I'm just going to put that in there, and this one transitions at 2/3. So I've just added x is a negative 3 and x is 2/3 to the graph, because this first one here, x is negative 3, is where this inequality transitions, and this one here is where this inequality transitions. Now we're wanting to add these, so how are we going to go about that? So let's look at what happens to the left of negative 3. We can see that mod x plus 3 is represented by this limb here, y is negative x minus 3. If we look at mod 3x minus 2, that's represented by this limb, which is y is negative 3x plus 2. So when we add, we're going to add the limbs that represent the modulus function in this region. If we add those together, we get negative 4x take away 1. Now let's look between negative 3 and 2/3, so between the two red lines. Mod x plus 3 is now represented by this limb, which is y equals x plus 3. But in between here, the mod 3x minus 2 is still represented by negative 3x plus 2. So we need to add negative 3x plus 2 and x plus 3. So we're adding these things together. So that's going to be negative 2x plus 5. Finally, let's look what happens to the right of 2/3, so over this way. Now mod x plus 3 is represented by x plus 3, indeed as it was before. But now we're to the right of this red line here. The other modulus is represented by 3x minus 2. And if we add those, we get 4x plus 1. So let's look at that on the graph. So we've got a portion here that's negative 4x take away 1. Then we've got this portion here, which is the 2x plus 5. And then we have this portion here. Let's get rid of the other lines, and this is what this graph looks like. And just to recap, it's negative 4x minus 1. I'm not sure I said that quite right earlier on, but it is negative 4x minus 1, this bit. But that changes when x is negative 3. Between negative 3 and 2/3, we then get negative 2x plus 5. And then from 2/3 onwards, it transitions again into 4x plus 1.